Welcome back. So I'm using mathematical function. I'm using the mathematical library. Okay. So how we will use mathematical library? By doing this, by calling this mathematics library and then using this double colon and then pi. Okay. So I'll be using this pi value. So as I told you as in the earlier on my second on the my last video, that what is pi? Pi is basically the ratio of the circumference of a circle to its diameter. Okay, so that is pi. Now I will be using a for loop. Okay, uh, I hope you all know how to use for loop. Okay, so what I will be doing, how I will start. I will use a variable. You know how to use for loop. You have to give a starting value, then you have to give the limiting value, and then you have to increment that value. Okay. So starting value will be 1. Okay. Then maximum value means how many iterations it will have will be equal to total terms. Okay. And then I will increment this I variable by 1. Okay. Now I will again use mathematical library and I will use sine function of the mathematical library, and I will name this variable as I will store this whole value into a variable, and I will name it as sine low. This function will have low frequency. Since it's a sine function, then you will have to give some values to it. Okay, so right now just give it a value $I. Okay, and let's have a phase. Let that have a phase difference. Okay, so I have added a phase. Okay, I have added a phase to it. Why I am doing this, you'll come to know. Let us create a second value, second variable. This will also have sine stored into it. Okay, and I will use this $I variable to evaluate the sine values at different iterations. Okay, now you can see these two waves are similar, but there will be a phase difference of pi between these two waves. Okay, so I just created so that later on you will appreciate that why I added. I will show you everything. Okay, now as I told you, this will be a very high frequency wave and this will be a low frequency wave. So if it is, right now both of these waves are having similar frequency, same frequency, not similar, same frequencies. But what I have to do is I have to increase the frequency of this wave, and you must be knowing how to increase the frequency of this wave, because you all must be familiar with sine function. Okay, so let us multiply this dollar with 200. So the overall frequency, this will be overall frequency, and this overall you can say the overall value the oscillations will increase. Okay, it will have 200 oscillations till this completes one oscillation. So I have done this thing. Okay, now what, as I told you earlier, that what is modulation basically. So modulation is what? It is the sum or superimposition of these two variables, is these two waves actually. Okay, so let us create a third variable called sum not sum